What is a message? The message used to be like this, okay, A, B, C, D, E, F, like that. They used to give a very big message. Based on that, we used to figure out the frequency. Is that correct? Yes. Okay, based on the message, they used to give a message like this, A, B, C, D, E, then again A, C, D, E, like this. Based on that, we used to figure out the frequency. But this is one more step up. But what if they themselves have given the frequency and all? Then we don't have to do the, okay, one step for us is fully, avoided, which is easier. Okay, so what if they themselves have given? So that's what you see as a question in your internals. What is the question that was given? Okay, and what is the thing to be kept in mind? The thing to be kept in mind here is very simple. Okay, first you can see they themselves has given what is known as a question. What is the question? They have said there is, characters like this. What are the characters they have given? The characters they have given is like this. There is A, P, then C, then D, then there's an hyphen like this. And they have even given the frequencies of it. What is the frequency they have given? The first, be careful, this is an hyphen only. They have given it as hyphen only, so I'm going to take that only. Okay. What is the values they have given? It is 0.4, 0.1, and this is 0.2. This would be 0.15, and this is 0.15. That's all. Now, the first thing that you got to keep in mind is you just try to figure out, okay, what is the total aspect of it. There is no need, if you can sort of understand, if you can do it neatly, there is no need, but always a better option is to make sure that you figure out what is the total aspect of it. Okay, what is the total you get for it? 0.45, 5.5, 0.7, 0.7, 0.85, 0.85 plus 0.15. So this you get it up to 1. Okay, you get it up to 1. This is something that you got to keep in mind. Next thing I told you that everything, first step is among this, if they have given like this, the next thing they have told is please make sure that you're putting everything in ascending order. Yes, I'm going to put it in ascending order because I need to write a tree, right? I need to write a tree, so I'm going to put everything in an ascending order. If I put this everything in an ascending order, how do you think it will be coming? It will be coming like this. Okay, which is the smallest one? There's a B. Okay, I'll be writing below. Okay, there's a B here. And what is the value that you get here? For B, it is 0.1. Okay, be careful with that, with the values and all. Okay, how you write values, everything. Next, then the next one is after that there is C. No, there's not C. There's D and hyphen. You can write like this. There's D and the next one is hyphen. What is the values that you get? 0.15 and also 0.15 for those two. Okay, two things which you got to keep in mind. Next thing. Okay, see this? Two things are done. What's the next thing? Next thing is C. What's the value of it? 0.2. Next thing is A. What is the value of it? 0.4. Okay. Check whether you have written everything properly. This is called, being careful. Okay. See, you go wrong here, no one will save you. That's a thing I'm saying. Okay. You got to be careful of doing things. Have I written everything? Okay. Have I, written everything that's been given here? Yes. Don't be in a hurry in doing problems like this. Okay. Got to make sure that you're doing everything. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everything is written. Fine. Next, you need to create trees, right? So you create trees like this. Two things will match. Okay. What is 0.1, 0.15? What are you going to get? 0.25. Correct. What is the value that you're going to get? 0.25. This is the next thing. Now you check. 0.25, 0.15. I think you get 0.4. 0.15, then 0.2. What are you are going to get? Be careful with this. This is where people will generally go wrong. Okay, that should not happen. 0.15, then 0.2. This will become equal to 0.35. So which is smaller? This two itself is smaller. Okay, these two itself are smaller ones. So what we are going to do? We are going to join these two. And what is the value you get? 0.35 without any problem. Now you check 0.25, 0.4, 0.35, 0.4. Okay, which one you are supposed to get? Obviously, you are going to join 0.25 and 0.4. See, you cannot join it here. If you join also, it will become all messed up and all. Okay, so what you can do is, one neat thing you can do is, you can take one more step, just one more step and write it towards below. Okay, what is the thing that you can write? 0.25 and 0.4. Right, 0.25 and 0.4. So what is the value that you're going to get? Be careful, 65. Okay, you're going to get 0.65. So let me go back and check with the values of it. 0.65 I'm going to write. Okay, the left hand side I am supposed to get 0.25. Okay, the right hand side I'm supposed to get 0.4. Okay, which is nothing but A. Okay, which is nothing but A, and towards the left hand side 0.25 as two more subtrays. What are the two more subtrays? See, this is all something which you have already learnt. So make sure that you people are not forgetting this. Okay, what is it? This is nothing but B and D. This is with the value 0.1 and this is with the value 0.15. But is that the end of it? No. There is one more thing here. Check here. See, 0.65 you got. Okay. These two things you joined. What are the two things you joined? You joined this one and of course this one. But what about this one? That needs to be joined now. Okay. If you join that 0.65, 0.35, it will become 1. Are you getting 1 here? Check here. That the total was 1 only. So are you getting 1? Yes. This is called cross checking. Okay. This is called cross checking and making sure that whatever you're doing now, it's all fully correct without any problem. That is something that you got to keep in mind. Okay, so let me go back and again join these two things. If I go back and join these two things, I'm writing towards the left hand side of it. Okay, so let me write it here. Okay, so I'm going to write the final aspect of it to be like this. You will be getting 1. Towards the left hand side, I'm going to use this. Okay, so it is 0.65. Towards the right side, I'm going to use this. So it will be 0.35. Okay, 0.35 as two subtrays. Okay, which is nothing but this hyphen and the next one being your C. Okay, this 0.6 has again two subparts like this, right? This one will be 0.25 and this one would be 0.4. Okay, and this is nothing but B. This is nothing but D. Okay, now what is the most important part here? You need to figure out whether you have got everything. Okay, you need to got everything. What is 0.4? 0.4 was A. So check out that. A, have you got it? Yes. B, where is B? Got it? Yes. C, C. Okay, then D is also fine. Then what's the next thing? Hyphen. Hyphen also you got it? Yes. Okay, this basically means that you have got for everything. Okay, you basically got for everything. You see, have you got for everything? Yes. Now what is the next thing? Next thing is very simple. Put the codes for it 0, 0, 0. Then again towards the left right hand side will become 1, 1. This left hand side here 0. This right hand side here 1. Then again 1. Is that the end of a tree? Yes. Okay, that is very much an end of a tree. Okay, something that you got to keep in mind, that everything you got. See, that's the end. Okay, no more admission with regard to class. If you're coming 15-20 minutes late, it's not gonna work. Okay, now that's it. Okay, now look into this. Okay, look into the aspects of this. You again add this entire tree done. Now our job is to make sure that we are going to write a code for it. That is step number 2. Write a code for each and everything. What is the code for A? Be careful. Okay, A, where is A? Here. So what is the code for A? 0, 1. Then again B. Okay, what is B here? B is here. So it is 0, 0, 0. Then again C. Okay, C code is nothing but 1 and 1. Then D. Okay, D where is here? Here. So 0, 0, 1. Then hyphen. Okay, what is the code that you have? Code is here. So 1, 0. Okay, so everything you got here. Everything you got without any problem. But this was not the end of a question we have. The question had even extra things also. What were the extra things? Okay, the extra things was with regard to. Okay, the extra things was with regard to. They are even said, please encode. Okay, please make sure that you are encoding a message. What is that message? A, B, A. Okay, then C, A, B. Okay, then A, D. You need to encode this also. That is what they are told. Okay, That is what they are told. Now that's what needs to be done also. Okay, that's what needs to be done. So we are going to look into that. Okay, we are going to look into that now. So what, 1 second. Okay, now we need to encode this, right? Encode this means what? We are going to write a message for it, nothing more. Just have to write wherever you got A, you're going to write 0, 1. Wherever you got B, you're going to write 1, 0, 0. Then A, so again 0, 1. C, so is 1, 1. A, again is 0, 1. Then B, okay, you got 0, 0, 0. Okay, then again A, 0, 1. Then again D, you have 0, 0, 1. Over. Encoding of message is over. So the second step is also over. One was to figure out the codes. How did you figure out the codes? Using the graph tree. Okay, the Huffman tree. We know these things of writing this. So we did this. Using Huffman tree, we did all these things. Then the codes we wrote neatly. Then you see the encoding part, we also did that. Okay, now that's not the end of it. They are saying you need to please decode. Okay, they're saying even the continuation of the question that says you need to decode the question, you know, the things that they are given. What is the thing they are given? 1, 0, 0, 0, 1, 0, 1, 1, 1. Okay, then 0, 0, 1, 0, 1, 0. This is a message to be decoded. How you can do this? Okay, see how you can do it is very simple. Check for whatever they have given here and figure out whether you are going to get it from this. Okay, see this 0, 1. Now check for only one. Is there any only one here? No. Then check for 1, 0. Is there 1, 0 here in any of these things? Is there 1, 0? Yes. Okay, and what is called that? You call it as an hyphen. Okay, then again the next thing you check. Okay, is there the next three parts? What is the next three parts? Okay, you check only 0 is there? No. 2 zeros are there? No. Okay, then you have 0, 0, 1. See this? Do you have 0, 0, 1? Yes. You got your 0, 0, 1. And what do you call that? You call it as D. Okay, then again you check 0, any 0, a single 0? No. 0, 1? Yes, you have 0, 1, which is nothing but A. So figure out those two things will become A. Okay, then again single one you have? No. Double one you have? Yes. What is the double ones we have? C. Okay, you have C's. Next thing, again single 0? No. Double 0? No. Triple 0? No, that's not triple 0. 0, 0, 1. You have 0, 0, 1? Yes. What is the message? D. Okay, then again you check single 0? No, it's not there yet. Then 0, 1, check for 0, 1. Yes, it is there. Okay, but that's not the only thing. Okay, that's not the only thing. You see very clearly, is it 0, 1? Yes. Okay, and do you have any one like this? No. 0, 1, 0, do you have? Check this. 0, 1, 0, do you have? No. Okay, but do you have something like 0, 1? Yes. So that you can write it here. I think this 0 was not there. Okay, just remove that. See, the message is gone. Did you encode everything? Did you encode everything with regard to it? Yes. Without any problem, I sort of encoded everything. First was 1, 0. Okay, the first was with regard to N0. Sorry, 1, 0. Then the next thing was with regard to three things. Okay, so even that is done. The next thing is with regard to 0 and 1. See, even that is done. Okay, then you got 1, 1. Yeah, that is done. Then you got the next thing 0, 0, 1. Okay, check this 0, 0, 1. You had D. Same thing coming. Okay, so this is also done. Then again, you had 0, 1. This is also done. So the message, the decoding of the message is what? Hash D A C D A. Got everything? Yes. Okay. Without any problem, did you get everything? Yes, no problem. You got Huffman trees, you wrote, got the code, is you call it as what? Huffman tree. Okay, what do you call this? You call it Huffman code. What do you call this? You call this as encoding of a message. What is encoding? Wherever the message is given, for that you are trying to figure out what is known as the code for it. And this was decoding. Okay, this is with regard to decoding. Generally, what happens? 2 marks each. 2 into 4. 4 operations are there, right? But 1, 2, 3, 4. 4 operations, so obviously 8 marks. So it should be either 8 marks or more than 8 marks, not less than that. Okay, not less than that. That you got to keep in mind. That it is either 8 or more than 8. Okay, it will never be less than that. Okay, this is the most important part with regard to Huffman trees and all. How we are going to figure out, okay, what is the way of writing a tree code and all, encoding, decoding, everything will be coming like this. Okay, most important way of looking into things. Done. So let now go back into the next part of the last part of our greedy technique called, okay, it's not greedy technique first of all, it's called transform and conquer. Okay, be careful with the wordings there. It says what is the thing that you're going to learn here? You're going to learn about a concept called transform and then conquer. Okay, now before we sort of move into this, I think there's few things that you got to think. What is the first thing you learned? The first thing you learned was with regard to divide and conquer, correct? Okay, you learned something called as a divide and conquer. The next thing you learned was when it comes to, remember when you had the last part of your second module. Okay, the last part of your second module, you learned something called as topological sorting. There, you learned a topic called as decrease and conquer. Okay, it's called decrease and conquer. Next, you learned a technique called as greedy method. Okay, you learned a greedy method and all were till Huffman tree, whatever you learned, okay, right from coin change problem to Huffman tree, everything came across thing called as greedy method. Okay, then now you're going to look into just one concept under a thing called as transform and conquer. Okay, very important for you to sort of get to know this. Okay, so what is the thing that you got to see in this? Okay, what is the thing that you got to see in this? In this, you are going to learn only one topic, which is all about heaps. Okay, why this becomes very important is whatever the graph way you learned just now, the same thing is going to continue. Okay, you're going to learn about heap. No, so first of all, what do you mean by transform and conquer? There will be a problem like this. So this is a main problem or the original problem. You are going to sort of transform that. Okay, this is very important. Okay, you are going to transform that problem into something else. Okay, how do you think you can transfer? There are various techniques for it. See, all those things is not there for you, unfortunately. Okay, and then you are going to find a solution for it. Okay, so what is it? You are going to transform into some other way. Okay, some other form, and then what you are going to do? You are going to find a solution for it. Then if you find a solution for it, you are able to find a solution for the main problem. That is called as transform and conquer. Okay, so you're going to transform your problem into something else, and then you're going to find solution for it. Then that clearly means that you're finding a solution for the main problem. Okay, so based on this, there are various examples that you can do. What are the various transform and conquer technique that you have? There are so many things. For your syllabus, there's only one thing. Okay, that is with regard to heap. Okay, there's only one thing called heap that only you are going to study. Okay, that's all is the entire thing. Okay, once you study all those things, the entire 3 models will be fully done. Okay, so let me go back and sort of look into what is that entire thing. Okay, I hope the screen is visible. See, it's been written in a line, what do you call, ruled book. Okay, so probably if possible, I'm going to convert this into that unruled one and I'm going to send it. Okay, otherwise you can sort of manage with this. Okay, see what is heap and heap sort? That's a concept which you're supposed to sort of learn and all. So what is heap and heap sort? Okay, see there's a heap and a heap sort. Two things that you got to keep in mind. Heap is what? Heap is a complete binary tree. Be careful with the definition of it. Complete binary tree or a almost complete binary tree in which, be careful, every parent node must be either greater or lesser than the child nodes. Okay, every parent root node or a parent node will be either greater or lesser. So based on this, again you have two things here. Okay, what are the two things that you have? The two things you can see very clearly are with regard to maximum heap and minimum heap. So what is maximum? What is minimum heap? Very simple. When you think of maximum heap, okay, what is it? It's a tree in which each node, you can see this, each node is greater than or equal to. So what is the thing that you can say? I'll give an example, don't worry, okay? In a maximum heap is each node in a tree where it is either greater than or equal to its value that is there in its child node. Example for it, very simple, you can see this example. Okay, see this example. Look into what is the first thing you need to see. I need to see root node. Okay, this is root. Is it greater than its children? 12 and 4. Yes, no problem. But this is not the only thing that you need to look. You need to look into this also because this also has children. 12 has also children. So you need to check for 12 this one also. Whether its children are lesser than this. 11, 11. Yes. So this property is satisfied. Then look into this 4. 4 doesn't have children. No worry. So this is a maximum heap. No problem. Because all the nodes has the value greater than or equal to its children node. Okay. Each and every node needs to be calculated. Each and every needs need to be taken care. The entire problem of heap sort believes on this. Okay. We'll all fall on this. If you know this concept, problem is over. By tomorrow, problem is over. Okay. 18, see this 12, 4. 18 is only greater. 12, 11, 11. 12 is only greater. 4, there is no children, no worry. Come to here. 10 is greater than 8. Yes. 8 greater than 7. Yes. Is this a maximum heap? Yes. Okay. Now again go back. Maximum heap. A tree in which each node is greater than or equal to the value of its children node. If this is maximum heap, the next one would be minimum heap. Okay, what is minimum heap? A tree in which each node less than or equal to. See this? Less than or equal to what? Its children values. Less than or equal to its children value, that you call it as minimum heap. Okay, and what is the values for it? What is the examples for it? Look into this. Each and every node should be less than its children node. 4, 12, 14. So I am only less. 4 is only less. 12 you go. 12, 20. Equal is there. Fine. Equal is fine. 20 greater than. So this is fine. So this node is fine. This node is also fine. Check for this. There is no children. No worries. Come here. 7. Okay. 15, 18. No problem. 15, 20, 25. No problem. 18. There is no children. If you want to build a minimum heap here, what you are going to build? You put a very big value, either 18 or more than 18, maybe 19. Then one more tree if you want to put. What is the value that you get? You put 20. Is this a minimum heap now? Yes. Okay, this is 20. Put it like this, 20. Okay, is this a minimum heap for you? Yes. That is also fine. So you got two things here. Okay. Two things that you got to know here. What is the two things that you need to got to know here? Okay, two important properties. First one, it should be a complete binary tree. No doubt in that. No doubt in that. Second one, it should satisfy parental property. What is parental property? Whatever you studied till now, maximum heap, minimum heap, that only is parental property. So parental property means either it should be greater, maximum heap, or should be less, minimum heap. No here and there. Okay, one node is greater, one node is smaller. Okay, if you write like that, you are dead. That should not happen. Okay, that should not happen. You need to make sure that you are getting this parental property, everything without any problem. Okay, so let me go back now. Okay, let me go back, or else Let me show once again. Okay. So what is the next thing that you got to keep in? Okay. The technical terminologies, the representation of heap. Okay. Where do they come under? The root node will always be placed at a of 0. This is in terms of, computer science I'm talking about, a of 0. The left child, any left child. Okay. Any left child if you take, okay, will be placed in 2i plus 1 position. 2i plus 1 position. Then if you take right child, okay, it will be placed in your 2i plus 2 position. Plus 1 plus 2. What is I? I is nothing but level. So based on the level, those values will change. Okay, based on the levels, these values will be keep on changing. That you got to keep in mind. Okay, look into this example. Okay, look into this example, you will get to know. This is a of 0. Then what is this? This is level 0. This is level 1. Level 1 is, you can see very clearly what is the value that is going to get. Okay, 2i plus 1. Okay, so what do you call this? 2i plus 1. 2, this will be equal to, okay, 1. 2, 1 plus 3. So this is third position. Okay, this will be fourth. Then again, this is fifth, sixth, seventh, like that. It will be keep on going. Okay, it will be keep on going like that. Okay, when you put it in form of a array representation, this is what it will be. Okay, but based on this, what are the things that we can learn? They're saying, yeah, construct a heap. Okay, 14, 12, 9, 8, 7, 10, 18 they have given. Okay, now you need to construct a heap. That's what the question is given for your internals also. I don't know how many if you have it. Please check in your what is that assignment questions will be having. But you need to construct a heap. I'm not asked for any theory properties on all. Everyone knows theory. Okay, I've given what is known as the first thing. Okay, which is with regard to figure out a heap thing. Okay, there are two properties of way of doing it. One is known as top-down approach. Let me go back to my screen. Okay, so there are two ways of doing what is known as this heap or generating a heap. Okay, first one is known as top-down approach or bottom-up approach. First we will be going with bottom-up. Bottom-up approach, very important approach. Majority of whatever we do will be based on this itself. Second one is if there is bottom-up, obviously there is top-down. Okay, so next thing is with regard to top-down approach. This is very important. Bottom-up approach. Okay, very important. Now, what is our job? Our job is to make sure that we are constructing a tree. Okay, so what we are going to take, we are going to take one example and I'll show you how it needs to be done under simplest of way we are going to do. Okay, all these things are problems. Okay, see, you need to consider these as problems. Remember your maths, remember your DMS, remember your DA. All should come in same old way, same old fashion. Okay, even in fifth sem, you will be having just one. When you go to fifth sem, I hope everyone will be going into fifth sem. Okay, you have one more, problematic subject. Okay, there's one more problematic subject. There's only one problematic subject. That's the right way of talking about it. And that's a last problematic subject you have in your entire engineering. Right from 6th sem, 7th, you will not be having any problematic subject. Either you have a theory subject or a programming subject, except no problematic subject will come. Only up to 5th sem only it will work. Here you have probably I think you have maths. Okay, that's all only things. Okay, then all other things it's all idiotic subjects. Okay, you can always manage without any problem. MES a little bit of lab if it's not a problem. But in 5th sem again you have one problematic subject. So you can think, okay, how the things would be, who will be doing it and all. Think about it, okay? Now, what's the next thing? We are going to construct a heap for it. Now, what we have taken from the notes is, we have taken this example. 14, 12, 9, 8, okay? So can I write this? Yes. I'll be writing what is the thing that's there, okay? 14, 12, 9, 8, okay? Let me go back to the next one. 9, 8, 7, 10, 18. That's what you have, okay? Got 7, 10, Is that 7, 10, 18? Okay, is that the end of it? 1, 2, 3, 4, 5, 6, 7. So we have 7 nodes here. Yes. Okay, 3, 4, 5, 6, 7. Yes. Okay, so let me now go back to this. What's the first step? Okay, what is the first step? Step number 1 is very simple. Okay, step number 1 is quite simple. What is that step number 1? Make sure that you are drawing a binary tree. Make sure that you are drawing a binary tree. How you need to draw a binary tree? Very simple. Go with the flow. Okay, go with the flow. That's what people say to you. See, first step is draw a binary tree. Go with the flow. That's what people say. What is that? Go with the flow. Draw the tree. Very easy. Yeah. So what is the thing to be done here? Take these nodes. Take these nodes. Go with the flow like this. Very simple. First thing is 14 is there. Okay, I'm going to make this as the root node. Then 12 is given, left child. Okay. Then 9 is given, right child. They will not be having third child. Okay. No 3 children, 4 children, only 2 children. It's like our Indian laws. Okay. 2 people, maximum 2 children. If you have more than 2, then you have some problem. Okay. Now 12 and 9. That's all. Okay. Then again, next one is 8. So you're going to put it here. Now don't put 7 here. Don't do it randomly. 7 should be coming here only. Okay. Then 10. Then again 18. Just draw binary tree. What is binary tree? Binary tree will not check whether the values are greater or lesser and all. It only checks whether each and every node has a correct 2 nodes or not. That's all. Have you got it? Yes. It will only check whether every nodes is a complete, it's a binary tree or not. There are 2 things in this. Okay, one is binary tree, and next one is complete binary tree. Okay, people, you must be remembering these 2 things right from your data structures or from your DMS. DMS I think is very less data right from data structures. Okay, so this, it's all done. This is all done. Have I done the same thing here? Yes. Look into this. Have I done the same thing? 12, 9. Don't see this one. Okay. See this one. I've done everything here. No, yes, I've done the same thing. Without any problem, I've written the same thing. Okay. Now my job. Okay. Now my job is to make sure that what is the thing I'm trying to figure out here. Okay. I need to write what is known as a max heap. Right. I'm trying to figure out step 2 is to make sure that you get a max heap. It depends. You can write minimum heap also, max heap or minimum heap. Okay, max heap or minimum heap. So if I take one example, say max heap, which is nothing but all the nodes should be what? It should be greater than or equal to the each and every node. Okay, how you are going to do that? Very simple. I told you that you are going to start with the bottom up approach. So you just figure out. First, start from here. Is 8 having any children? No. 7? No. Okay. Then go to 12. Okay. Go to 12. 12 is having children. I'm talking about maximum heap. Okay. Minimum heap probably we'll see that later. Okay. I'm talking about maximum heap. What is the meaning of maximum heap? All the nodes, okay, should be either greater or should be equal to its children. Okay, it should be either greater or equal to its children. This is very important. So to check with regard to 12, is it greater than 8? Yes. Greater than 7? Yes. Not a problem. Go to 9. Go to 9. Okay, 9. Greater than 10? No. Greater than 18? No. So what do? You interchange this. You swap this. Okay, you need to write that swap 9 and 18. Not right here. You have to write it below. Okay, you have to write it below and then you have to again draw the tree. Okay, again you have to draw the tree. So you're going to swap 9 and 18. If you swap 9 and 18, okay, swap 9 and 18, what is the tree I'm going to get? Can I write it towards the right hand side of it? Okay, I'm going to write it here. So what is going to happen? You're going to get like this. You get 14 here, you got 12 here, okay, and here you're going to get 18. See, be careful, I'm swapping their position, which basically means in place of 18, I'm going to get 9. 12, for me, it's not a problem, so I'm going to get 8, and this is 7. And this would be obviously 10. Now you check again you check. 12 for me was not at all a problem here. So 12, 8, 7, so it's not problem. 18, 10, 9. 18 is also not a problem. Now I go on, see these two things, this is also done. There's no children only for them. So these all things are all done. They're all for, equal, they're either greater or equal to its children. Okay, now the last thing. What is that root? Check for root. Root, check here 12. Okay, greater, not a problem. But 18, not at all, greater. You need to swap these. What is swap? Swap 14 and 18. You need to swap 14 and 18. If you swap 14 and 18, what is going to happen? Can you get a maximum heap? Yes. So if I do that, okay, if I do that, can I write here itself? Okay, or else one more step only now. Do it just 2 minutes. Just going to finish this off. Okay. You can see it's very simple, right? Yeah, it's very simple only. But common sense, the common sense need to prevail every time. Okay, so I'm going to write it. This will become 18 here. This towards this side it will become 14. This again it will become 12. Okay, this side 9. Sorry, 10. This side it is 9, and towards this side it is 8. This is 7. Now you check each and everything, each and every node. This I'll very easily say this is a max heap here. Okay, why? Very simple. 18 greater than 12, 18 greater than 14, 12 greater than 8, greater than 7, greater than 10, greater than 9. Is this a max heap? Yes. Okay, did you follow bottom say top approach? See this. Yes. Is that end of a problem? Obviously. That's all. Okay, that's all is a problem. First step, write a binary tree. Second step, construct, max. They will be giving it, right? Maximum heap or minimum heap. They'll be giving it. If they are not given it, obviously, by default, it is maximum heap. Okay, maximum heap, construct it without any problem. Maximum or minimum heap, construct it. Fine. Okay. If because it was maximum heap, it was, it took only 2-3 swaps. If it would have been minimum heap, it will take lots of swaps. That we are going to do it in the next class tomorrow. Okay, tomorrow we are going to complete this entire module without any problem. Fourth module we'll see. Okay, that one topic is their theory topic. Possible we'll do, otherwise Saturday we'll do something else. Okay, yeah, fine. So this is with regard to maximum and minimum. Okay, very simple. Understanding thing is